Welcome to my YouTube channel. Today, we are going to talk about a very interesting topic, which is water. All right? Water, as we know in chemistry, the chemical formula is H2O, which shows that water comprises of two important elements in chemistry, which are hydrogen and oxygen. Okay? We are going to describe water based on their physical properties and their chemical properties. But first, let's look at the sources of water as some important properties and components of water. We're going to look at sources, properties, and components of water. First, sources of water. One is rainfall, stream, sea, ocean, well, spring, and so on. These are the sources of water. All right? Then number two, looking at the properties here. Pure water is colorless and odorless. Number three, pure water has insipid taste. Pure water has insipid taste. This means that pure water is tasteless. All right? Pure water is colorless and odorless. Then pure water also has insipid taste, meaning that pure water is tasteless. All right? The number four. Water has no effect. It has no effect on litmus paper. It has no effect on litmus paper. The number five. Water boils at 100 degrees Celsius. Water boils at 100 degrees Celsius. Water freezes at 0 degrees Celsius. It freezes at 0 degrees Celsius. Number seven. The maximum density of pure water is 1.00 gram per cm cube at 4 degrees Celsius. This here on the board are sources, properties, and some important components of water. All right? Number 8. Water constitutes some impurities. Water constitutes some impurities. This water that constitutes some impurities are not pure waters. All right? Now, these impurities here comprises of dissolved gases. It comprises of dissolved gases. meaning that rainwater, stream water, sea water, ocean water, well water, and spring, they are impure water because of the presence of some certain degrees of impurities. Take for example, rainwater here. Rainwater consists of about 0.001% of impurities. All right? Of impurities. While the seawater consists of about 2.6% of impurity. All right? So, meaning that these waters we have here, these sources of water, the waters are impure water because water comprises of dissolved gas, which can be part of the impurities. Now, let's look at the constituents. The constituent gas in water. Constituent gases in water and their percentage by volume. Constituent gases in water and their percentage by volume. Number one is nitrogen gas. Nitrogen gas constitutes of about 63.9%. All right? Nitrogen gas constitutes of about 63.9% in water. Number two, oxygen gas constitutes of about 33.2% by volume in water. Then number three is carbon dioxide, which is popularly known as CO2, constitutes of about 2.9% by volume in water. Now, this constituent describes that water is a mixture, all right? Because of the presence of some certain degrees of impurities, it shows that water is a mixture. Now, the oxygen percentage by volume in water is 33.2. Are you following now? The percentage by volume of oxygen in water is 33.2. While the percentage of oxygen gas here in the air is 20.9%, approximately 21% of oxygen. This is the percentage by volume of oxygen we have in the air. 20.9% by volume or 21%. While in water, oxygen concentration in water is 33.2% by volume. This shows that we have more oxygen in the water than in the air. All right? And this simply describes that oxygen is more soluble in water than in air. In other words, because of the more percentage or concentration of oxygen in the water than in the air, oxygen is said to be more soluble in water than in the air. Now, we are going to look at physical properties of pure water. Let's look at the physical properties of water. Number one is that water is colorless and odorless. Water is colorless and odorless. Okay. Number two is water has insipid taste. Water has insipid taste means that water is tasteless. Insipid taste here means tasteless. Okay. Number three, Water has no effect on a litmus paper. Number 4, water boils at 100 degrees Celsius. Number 5, water freezes at 0 degrees Celsius. Number 6, the maximum density of water is 1.00 gram per cm cube at 4 degrees Celsius. Okay, here are the physical properties of water. All right, now we are going to look at the chemical properties of water. Let's look at the chemical properties of water. This here is the reactivity series. The reactivity series here will help us to understand the chemical properties of water. All right, so that is why I wrote it at this side of the board. Here is potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. All right? The one at the upper part are highly reactive. All right? The one at the lower part are non-reactive metals. All right? As you are going down the reactivity series, from up to down, the rate of reactivity is going down. That is to say, the rate of reactivity is decreasing, meaning that potassium is more reactive than sodium, which is more reactive than calcium. All right? And calcium is more reactive than magnesium. Magnesium is more reactive than aluminium, which is more reactive than zinc and iron. All right? Then tin is more reactive than lead. Lead is more reactive than hydrogen. Then copper, mercury, silver, and gold. As you are going down, the degree of their reactivity is decreasing. All right? Now, the chemical properties of water here has to do with the chemical reactions of water. All right? So we are going to look at the chemical properties of water based on its reactive or based on its reaction with metals, non-metals. Number 3, let's call it basic oxide, the oxide of metals. Then number 4, acidic oxide. Okay, we are going to look at the reactivity, the reaction of water with metals, non-metals, basic oxide, and acidic oxide. Let's see how water behaves when it reacts with metals, non-metals, basic oxide, and acidic oxide. All right, here for metals. Metals is categorized into 3 based on its reactivity with water. Metals on the board is categorized into 3 based on its reactivity with water. Number 1 is active metal. Number 2 is semi-active metal. Number 3 is inactive or passive metals. Metals are categorized into 3 based on its reactivity with water. We have active metals, we have semi-active metals, we have inactive metals, which are described on the board as passive metals. Now, let's look at the active metals. Active metals are those metals that react with water because they are very reactive. That's why they are called active metals. All right. So these active metals here, they react with water to displace hydrogen in water as a gas and form basic oxide. All right. Active metals are those metals that are highly reactive, which when react with water liberate hydrogen gas. Do you understand? Active metals are those metals that are highly reactive, which when react with water displace hydrogen in water in form of gas and produce basic oxide. Do you understand? Now, the active metals here are potassium, sodium, and calcium. These 3 here are the active metals. They are known as active, we can call them like this, active metals. They include potassium, sodium, and calcium. Take for example, sodium reacting with water. Remember, as we are going down, the rate of reactivity is decreasing, meaning that these 3 here are more active than these. All right? These are active metals, these are semi-active metals, and these here are inactive metals because they are non-reactive. Now, when sodium reacts with water, it's going to displace hydrogen in water. The hydrogen will go out in form of gas and to produce sodium oxide. When this reacts, it's going to give us something like this. All right? Then when potassium reacts with water, it's going to give us hydrogen gas is liberated because they are more reactive than hydrogen in the reactivity series. That is why they knock off hydrogen so that hydrogen will go out from the reaction as a gas, which we call the hydrogen gas. Then the basic oxide is produced. Do you understand? All right. Now let's look at semi-active metals. Here is number 1. Number 2 is semi-active metals. Semi-active metals, they don't react with cold water. They don't react with hot water. But they react with steam at a very hot heat. All right? They don't react with cold water. They don't react with hot water. But they react with steam at a very hot heat to liberate this hydrogen in form of gas. All right? Now here are the semi-active metals. They include magnesium, aluminium, zinc, and iron. They are known as semi-active metals. All right? They don't react with cold water. They don't react with hot water, but they react with steam at a very hot heat. All right? That means they cannot displace hydrogen in water. Are you following me now? They don't displace hydrogen in water unless heat is applied. That is when they cannot react with steam and not cold water. Are you following now? They react with steam, not cold water, to displace what? Hydrogen gas. Now let's look at the example here. Let's have magnesium here reacting with steam. The G represents steam, that is water gas, water vapor, as a result of high increase in temperature. Now it's going to give us what? Magnesium oxide. Then hydrogen gas is given off. All right? They can only displace hydrogen in steam and not in cold water or hot water. All right? So they are only reactive on steam to displace hydrogen, and that is why they are called semi-active, because they are not active in cold water, but they are active in steam, and that is why the name is semi-active metals. Metals that are active to displace hydrogen in steam to form basic oxide and displace hydrogen in form of gas. All right? Then we have zinc reacting with steam, the water gas, to produce zinc oxide, and hydrogen gas is given off. Then the last we want to look here is inactive metals. Let's look at this side of the board. Reaction with inactive metals. No reaction with cold water, no reaction with steam. All right? So therefore, no hydrogen gas. No hydrogen gas is liberated. And also, there is no reaction. All right? And since there is no reaction, there is no hydrogen gas liberated and nothing is produced. All right? And these inactive metals are, we have lead, we have silver, we have gold, and we have mercury. All right? Because they cannot displace hydrogen in water. Because they are very close, it cannot displace hydrogen in water, and these ones are less reactive than hydrogen. All right? So they are inactive metals because they don't displace hydrogen in water and there is no reaction. All right? That is why you can say that they are inactive or passive metals. All right? Now, the next we're going to look here is reaction with non-metals. Reaction with non-metals. These here are inactive metals. Take notes. All right. Here, let's look at reaction of water with non-metals. Non-metals like carbon and chlorine. Okay? Let's look at the carbon now. Steam All right. Steam is passed over white hot carbon to produce a mixture of carbon monoxide and hydrogen gas. All right. Carbon monoxide is also known as carbon 2 oxide. Carbon 2 oxide. Now let's look at the reaction. Look at the steam here. H2O, then gas. Because it's a steam, it's passed over carbon to give carbon monoxide, which is carbon 2 oxide, and to liberate hydrogen gas. Okay? Then secondly, chlorine gas dissolved in water to produce a mixture hydrochloric acid and monozochlorate. All right? Chlorine gas dissolved in water to produce a mixture of hydrochloric acid and monozochlorate. Look at chlorine gas here. Dissolved in water to produce a mixture of hydrochloric acid and hydrogen monoxochlorate. Okay? The equation is balanced. Chlorine gas dissolved in water to produce a mixture of hydrochloric acid and hydrogen monoxochlorate. That is all about the reaction of water with non-metals. Now let's look at the reaction of water with basic oxide. Reaction of water with basic oxide, which is chemical properties of water number 3. Let's look at the reaction with basic oxide, which is here the chemical properties of water number 2. What is basic oxide? Basic oxide, as we know in chemistry, are those oxides of metals that react with acid to produce salt and water. Then the active metals here that form the basic oxide, as we have here on the board, are potassium oxide, sodium oxide, and calcium oxide, which is also known as quicklime. Now, when this basic oxide reacts with water, when they react with water, they are going to produce corresponding hydroxide. They are going to produce corresponding hydroxide, meaning that if potassium oxide reacts with water, it's going to form potassium hydroxide. If sodium oxide reacts with water, it's going to produce sodium hydroxide. Then if calcium oxide reacts with water, it's going to produce calcium hydroxide, which is also known as slake lime. All right? Now look here. Potassium oxide reacts with water to give potassium hydroxide. Okay? Sodium oxide reacts with water to give sodium hydroxide. All right? Then the next is calcium oxide reacts with water to give calcium hydroxide, which is known as slake lime. All right? So when basic oxide reacts with water, it's going to produce corresponding hydroxide. And here, the sodium, the potassium hydroxide, sodium hydroxide, and calcium hydroxide, they are alkali. Why are they called alkali? Because these are bases that are soluble in water. They are soluble base. This is highly soluble in water. Sodium hydroxide is highly soluble in water. But this guy here, calcium hydroxide, is only slightly soluble in water. It is only slightly soluble in water. That is calcium hydroxide. All right? Because it is the least in the reactivity series of the active metals. The least reactive in active metals here is calcium. Now let's look at chemical properties of water number 4, which is the reaction with acidic oxide. Reaction with acidic oxide. Acidic oxide here are those oxides of non-metals. They are those oxides of non-metals that react with water that react with water to produce what? To produce acid. All right? We have some other oxide of non-metals that don't produce acid. They are known as neutral oxide. Neutral oxides are also oxide of non-metals. They are neutral. All right? They are nitrogen monoxide and nitrogen dioxide. All right? Now, we are talking about the acidic oxide. Acidic oxide here, they react with water to produce what? Acid. They react with water to give what? To give acid. They react with water to produce acid. And for that reason, they are known as acid anhydride. They are known as acid anhydride because they react with water to produce acid. Okay? All right. Now let's look at this acidic oxide that reacts with water to produce acid. We also have one that reacts with this water to produce double acid. The one that produce double acid or 2 moles, 2 molecules of acid. All right? And these ones, they are known as mixed anhydride. They are known as mixed anhydride. Is that okay? We have some acidic oxide that react with water to produce double acid or 2 moles of acid. Now, let's look at the acid anhydride, the one that produces 1 mole of acid. We have this. We have this. Then we have this. This is sulfur dioxide reacting with water to produce H2SO3, which is triazosulfate 4 acid, also known as hydrogen triazosulfate 4 acid. Here is an acid. React with water to produce H2SO4, which is tetraozosulfate 6 acid, also known as hydrogen tetraozosulfate 6 acid. Then carbon dioxide reacts with water to give triazocarbonate 4 acid, also known as hydrogen triazocarbonate 4 acid. Now let's look at mixed anhydride here. Mixed anhydride. Mixed anhydride are these are examples of mixed anhydride. All right? Nitrogen dioxide, phosphorus trioxide, and phosphorus peroxide. When this reacts with water, it's going to give us diazonitrate 3 acid, hydrogen diazonitrate 3 acid, and triazonitrate 5 acid, which is also known as hydrogen triazonitrate 5 acid. Then when this reacts with water, it's going to give us 2 mole of this acid. This will give us, and this is 3. All right? Then it's going to give us something like this. 3 plus 3 is 6. All right. So this is going to give us this. It's going to give us this acid here, which is double. Then H2O. Is going to give us this. All right. So here, this acid here are double, and these are 1 mole of 2 different acids. All right. So this is all we have for now. We looked at the chemical properties of acid with metals, non-metals, basic oxide, and acidic oxide. All right. This is all we have for now, please. In the next video, we are going to talk about the hardness in water. All right. the temporal and the permanent hardness in water, and we're going to talk about the ways by which this hardness in water is removed and what causes the hardness in water. Thank you and God bless you. Please don't forget to subscribe to our YouTube channel